All right, we're back. We're on page 6 of Notes 18, Calc AB. We're going to do some old AP free response, like super old AP free response questions. If you look online, I think you can find every question from like 1969 onward. And honestly, it's the best way to practice for the exam. It's a really good way to learn a lot of calculus. I mean, they ask questions that are like often a little different from how you'll see them in a textbook, which is mind-boggling since they've been asking questions that are a little different from textbooks for the last like 60 years. But you know, so go find those, do as many as you can. I like to include them in my classes. We usually wrap up learning around like March. I teach Calc AB, so we usually stop around March and just do as many free response questions as we possibly can between then and the exam. I teach another class called Calc CD where we finish like the BC curriculum in like near the end of December. And then we learn Calc 3 and then we start reviewing. So it's a little bit different there. But again, the key is as many free responses you can do. So let's see this. This is 1978 AB4. I was not alive when this problem was on the AP exam. But it turns out the math still works out. So let's do it. Particle moves on the x-axis so that its velocity at any time t is given by v of t equals sine of 2t. At t equals 0, the particle is at the origin. All right, so that's going to be probably important. For 0 to pi, find all values of t when the particle is moving to the left. So particle moving to the left would mean that v of t is less than 0. So I'm going to graph v of t. I think this is a super useful way to do this. I'm going to graph v of t. So the period is 2 pi over 2, which is pi. The increment is pi over 4. So we're going to go pi over 2, pi over 4, 3 pi over 4. So we're only looking between 0 and pi. And it's a positive sine graph. So we can go up to 1, down to -1, boom, boom, doom, doom. All right, so this is a graph of v of t. So moving left, when v of t is less than 0, therefore for pi over 2 t to pi. So the graph is incredibly useful. Like if you know how to graph trig functions, that is a superpower when you were in calculus because so many questions, especially about number lines and things like that, like we could have tried to algebraically solve this, whatever. You knew how to graph it, you graphed it, it works out perfectly. I highly, highly recommend that you review graphing, sine and cosine, shifting them up and down, changing the period. Not left and right, like the phase shift doesn't really come into it all that often, but up, down, change the period. Make sure you can do that. It'll help you all the time. Position. All right, so if you remember, we were told this weird thing. Well, it wasn't weird, but at t equals 0, the particle is at the origin. So that tells me the position at 0 is 0. So x of 0 is 0. So that's going to help us solve for c. So I'm going to do the integral of v of t dt should give me x of t. So that's the integral of sine of 2t dt, which is -1/2 cosine of 2t plus c. So that's x of t. So x of t is -1/2 cosine of 2t plus c. But we know that x of 0 is 0. So we can use that. So 0, it's getting really dark. Getting dark early. It's September something. 2 times 0. So it's just like literally just getting dark early. Like in a lot of my videos, it gets dark and I'm like, oh my God, there's going to be a crazy storm or whatever. Not here. Cosine of 0 is 1, so c -1/2 is 0, so c is +1/2. I mean, I feel like I made that more complicated than I needed to, but anyway, x of t is going to be -1/2 cosine of 2t plus 1/2. That is my answer for x of t. Therefore, all right, find the average value of the position function determined in the previous part. So like what, I don't know, like I have a hard time imagining like what the average value of the position function could matter. like on average, where is this thing? Like I don't know. But to do it, we're just going to do integral over interval. So we're going up one more level. We're going to do the integral from 0 to pi over 2, I think. Yeah, of x of t over pi over 2 minus 0, which is 2 over pi, the integral from 0 to pi over 2 of this thing, negative 1/2 cosine. They don't ask questions like this as often anymore, where like your answer to part C is fully dependent on your answer to part B, partly because I think the number of people taking the test has increased so much, and if you got part B wrong, now like your part C is guaranteed to be wrong, but like what they typically would do is read with you, right? So they would say like, all right, you got B wrong, but like assuming you had B right, did you do part C right? And it's like, who wants to do that for like hundreds of thousands of tests? No one. That's who. So let's see, this will be negative 1/4 sine of 2t plus 1/2 t from 0 to pi over 2. I'm hoping for a lot of like 0 type things here, which frequently happens. So when we plug in, yeah, here we go. When you plug in pi over 2 to here, you get negative 1/4 the sine of pi, but the sine of pi is 0, so that's gone. So you'll get 0 and then plus pi over 4 minus. When you plug in 0, you just straight up get 0. There were a lot of zeros as desired. And then so we get 2 over pi times pi over 4. We just get 1/2. The average position is 1/2. So I mean, does that make sense? I don't know. Like, I feel like it does make sense because the sinusoidal axis of the position function is 1/2. And then I guess the real question is like 0 to pi over 2, is that like what is that? So it's a negative cosine. So I think this makes a lot of sense actually, because I think that also I could be totally wrong, but you know, so the period is still pi over 2, and then it's going to be 1/2, and it's negative cosine. So you're like here, 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 here. Definitely feels to me like your average position on the interval from 0 to pi over 2 should be 1/2, right? Because like you're below it and like moving kind of identically to how you're above it. I think that makes perfect sense. I'm gonna check these on the calculator, even though the calculator did not exist in 1978. I'm gonna check them on the calculator, and then I will come back in the next one and do the next problem. I don't even know what it is. I don't know if it's long or not. It's just like, usually I do one free response question per video, so that just kind of like feels right. I'm gonna store v of t is sine of 2t. Solve v of t greater than less than 0 for t 0, nope, t to pi. Oh my god, what is that? How come I can't solve that? I don't know. Solve v of t equals 0 for t. 0 t to pi. At pi over 2, it switches. And let's see if v of pi over 2 plus 0.1. It's negative. So we got that right. Expression. So I'm going to do the integral of v of t with respect to t. Get this. And then what am I going to do now? So I need to do like plus c. And then I have to say like 0 equals the answer such that t equals 0. And then solve that for c. This is like a weird way to do this. I also could have used differential equation solver, probably a better choice. Menu for differential equation solver. I'm going to do x prime equals sine of 2t. And the independent variable is t. The dependent variable is x. The condition I know is x of 0 equals 0. And I think this is going to work. There you go. Kind of solves it for you. And then the average value is going to be, let me just get, well, what I just want to get this. Hold on. There. Okay, I'm going to do integral of the answer with respect to t from 0 to pi over 2 over pi over 2 minus 0. And we get 1/2. So I think we got it all right. Good job, us. I'm going to go back to the notes so you can see it, and then I will stop the video, and I'll be back in the next one to finish this page. Then we'll go from there. Making good progress. We can do like a lot of free response questions at this point. That's the goal. Be able to do every free response question, not be intimidated. All right, I'll see you in the next video.